Greetings all. Our primary goal today is to do a review of operations with signed numbers or integers primarily. And so I've prepared this video to go over those concepts. And of course you can ask questions when we meet in class. But beginning, without further ado, arithmetic with integers. Now, what do we mean by integers? Well, integers are your whole numbers plus negatives. So numbers like -3, -2, -1, 0, 1, 2, 3, 4, etc. No fractions, no decimals. And some practical needs we can think of course, right away are things like temperature, money, science, measurements, pH scales, that sort of thing, can be negative or positive. Actually, can pH be negative or positive? You'll have to look that up. So the easiest way to think about working with those is to consider the number line and assume in my classes that if I don't put a scale on my number line, I don't put numbers assigned to the tick marks here, that the scale is 1. But of course this would continue forever. The integers are known to be countably infinite. If you want to learn about that class, you can, or that concept, you can take a class called Math 130. All right, now further to the right on the number line, the numbers increase in value. And the further to the left, the numbers decrease in value. So an important concept to understand is what numbers are larger or smaller than others in terms of whether they have a negative or positive sign. So for example, if I'm going to compare, and we're going to be using the signs less than, greater than, or equal, as the case may be, then of course there's also less than or equal, greater than or equal signs. We won't be using those today, but this sign is actually read as less than. And this sign is read as greater than. You know, when you teach kids, you talk about the crocodile teeth, the crocodile mouth should always be facing towards, he's always hungry, or a bear, or whatever, piranha, chomp chomp, wants to chomp the larger value because they're always hungry. Anyway, and the arrow points to the smaller number. Anyway, ways that you can help remember what direction that needs to face. So if I have two numbers like -3 and 4, well, -3 appears further to the left on the number line than 4. So -3 is less than 4, and we would put that sign in the middle. If I have 5 compared to -9, again, 5 is further to the right on the number line. -9, while not shown on this number line, would be way further to the left, and so we would have 5 is greater than -9. What about -15 and -2? Another thing that's helpful here too is you can consider temperatures. What's colder? What's warmer? When we think about the negatives, oh gosh, it's coming. Winter is coming. -15 would be much colder than -2, but numerically it is further to the left on the number line, so -15 is less than -2. What about 2 and 3? 2 would be less than 3, but -2 would be greater than -3 because -2 appears further to the right than -3 on the number line. How about one more? Let's do -25 compared with -26. Try that on your own. Greater than or less than? Right, greater than. 25, -25, even though it's not shown on the number line, would be further to the right of negative 26. Thus, it is greater. And how about 0 and 2 and 0 and negative 2? 0 is less than 2, but 0 degrees is warmer than, greater than, negative 2. Another concept we need to know in order to prepare to add, subtract, multiply, and divide signed integers is absolute value. So a little review of what absolute value means, its definition, and then how we notate absolute value. So first of all, absolute value is a number's distance from 0. And it's notated with absolute value bars, so these straight bars. So when we say the absolute value of 3 is 3, this is because if I look at the number line, the number 3 is literally 3 steps, 1, 2, 3, away from 0. In a similar fashion, we would say that the absolute value of negative 3 is also 3 for the same reason, because from 0, it is 3 steps away from 0. So absolute value, as a result of its definition, is always positive for that reason, because we're talking about just how far away is that number from 0. So if we want to find the absolute value of these numbers, suppose we have the absolute value of negative 5. What would that be? The absolute value of 25. Right, 25. The absolute value of negative 11. The absolute value of 7. Now, we're primarily talking about integers today, but if I were to take the absolute value of something like negative 1/3, that would be 1/3, or something like the absolute value of 25.8, 25.8, its distance away from 0. Now, adding integers. The thing is, we're going to be working on, of course, today, adding, subtracting, multiplying, and dividing integers. And kind of like fractions, adding and subtracting signed numbers, integers, those processes are more involved than multiplication and division. The rules are very simple for those. So we're going to work on adding integers first. And we're going to take 2 approaches. The first approach is the number line approach. And remember, that symbol for me means number, not hashtag, not pound sign. And we're going to use a set of rules. So anytime you get confused or you forget the rules, you can go back to the number line thinking approach, which is basically this. I'm getting there. If you're adding a positive number, you move to the right. If you're adding a negative number, you move left. So adding a positive number, move right. And if you're adding a negative number, move left. Well, I know you guys can do things like 2 plus 3, of course, but if we were following this process, we would say, oh, I'm going to start at 2. So your first number is always your starting number. Start at 2, and I'm adding 3, so I move to the right 1, 2, 3, and get to 5. But the same idea applies if you were doing something like negative 2. plus 3. This just changes the starting point. So I'm starting at -2. I'm adding 3. So I move 3 to the right because I'm adding a positive number. 1, 2, 3. And I get to the value of 1. Now, some of you out there already remember these rules and already know this. For myself, the way I think about it is I think to get to 0, what would that take me? 2, and then I'd be 1 further. I'd have 1 left over to get to this value of 1. But following the rules, I'm going to follow the rules myself. Now suppose I have -2, same starting place, and I'm adding -3. Well, if I'm adding a negative number, that means I move to the left. So 1, 2, 3, that would take me to a -5. You try one. How about if we had 5 plus a -6? Right. You can always stop video at any time too. So starting at 5, adding -6 means we move 6 to the left. 1, 2, 3, 4, 5, and 6. How about something like -4 plus -5? Now I'm going to go off number line a little bit here, but you can imagine what's happening. So we're starting at -4, and I'm going to move 5 steps to the left. So where will that take me? Right, to -9. What if I have 3 or more being added together? 2 plus -3 plus a -6. Well, you can take this a couple of different ways. When you're adding, the beauty of adding, writing an addition, is I can put them in any order I want. 2 plus 3 is 3 plus 2. 2 plus -3 is -3 plus 2. We would get the same thing. So, and to illustrate that, actually, I should have done that. We'll do that in just a second. But I can do this in stages. So 2 plus a -3, 1, 2, 3 takes me to a -1. And now I have -1 plus a -6. 6 steps back to the left would give me a -7. But yes, I should have shown that at the first. Suppose we were doing 2 plus a -3. The process with the number line would actually be starting at 2, moving 3 to the left, or -3 plus 2. The process using the number line would say, oh, we'll start at -3, but we're going to move 2 units to the right, 1, 2. Illustrating what is called the commutative property of addition there. Let's try one more with multiples. Now for me here, I like to, actually let's wait, we'll wait on that one until we get to our rules for shortcuts. That's going to be a little long to describe with the number line. And so at this point, I'm going to go and create another video because YouTube will only let me do this in 15-minute increments. So come back for video 2, where we look at the shortcut rules for adding integers.